Welcome back to Visual Math Pi. So for today's topic, we'll be going over the arc length. So the arc length, we've done arc length before with things that look like this, and then we want the arc length of that, which is essentially just like the circumference around this portion right here, and that's more beginner stuff. So what we're gonna look at is a bit more advanced stuff. So how can we take the arc length of different curves essentially? Let's say that we have some sort of like parabola. Like, how can we take the arc length, which essentially is just like the length of this entire thing? Like, how would it look like? So this is where calculus comes into play, and we take a deeper look into this sort of thing. So a couple things that I want to mention beforehand is that y is equal to x squared, which is just the curve that we're given, and then 0 to 1 right here is just the bounds that we're given. So essentially the question is asking calculate the arc length of the curve y is equal to squared between the interval of 0 to 1. So visually, what that looks like is, so we're from 0, and then let's just say these are like other little mini points in between, and then 0 to 1, and then that's gonna look like something like this. Well, actually, if we want to be more accurate, that's going to look something like this. And it essentially wants us to calculate this curve length, which is just essentially the circumference, or like the perimeter, if you will, of a specific curve. So now that is done, one thing that is going to be crucial here is understanding the arc length formula, which is typically given or denoted by s, which is just going to be the square root of 1 plus the derivative of whatever function you're given, squared dx. So in order to proceed with this problem, we have to make a few substitutions. Like I said, s is equal to the arc length, which is equal to the square root of 1 plus dy dx, and then we can do that here on the side, which is just y is equal to x squared, and then the derivative of that is just dy dx is equal to 2x, and we obtain that from the power rule. So wherever we have a dy over dx, that's where we have to put in the 2x, which is just 2x squared. And then now that we have that in there, we have to incorporate the integration portion into this, which essentially just looks like this. S is equal to the S is equal to the integral of 0 to 1, which are the given bounds. And then we do 1 plus 2x squared dx. And now what we have to do is just do the integral of that. Here, let me erase this stuff here on the side so we can have a little bit more space. So in order to proceed with this, we have to do a bit of U-substitution. So why do we need U-substitution? So we need U-substitution to make things a little easier, and I'll explain why right here. So essentially we want this integral right here to look into the form of just square root of 1 plus x squared. And that's why we want a u, because we're essentially going to get something that looks like 1 plus u squared. And we want this, again, square root of 1 plus x squared, because the integral of that is actually equal to 1/2 x times square root of 1 plus x squared plus the natural log of x plus square root of 1 plus x squared. Right, yes. So we want it in this form right here, because we know that the integral of that is equal to this right here. And then I obtain this large, weird-looking expression from an integral table. And typically these integral tables, they'll be given on the exam, or the teacher will want you to memorize them, because if you don't have that integral table, trying to take the integral of the square root of 1 plus x squared is a bunch of long math that can be pretty tedious, which isn't the complete point of this. The point of this is to solve for the arc length. So yeah, if you were to do the integral of 1 plus x squared by hand, then you'd get like a bunch of cosines and sines, do some crazy trigonometry, calculus, and yeah, that would not be too fun. So yeah, I just wanted you guys to keep that in mind, that we want to get into that 1 plus u squared form, square root 1 plus u squared form, I mean. So let me erase this part right here. Next, what we want to do, I'm gonna just make a line here so we can show that we're doing our real work down here. And usually I make these little arrows on the side just to kind of show like the next step, if that makes sense. So s equals the integral of 1 plus 2x squared dx. And this is where we're going to do some u-substitution, and we're going to let u equal to 2x dx. So du is going to be equal to 2 dx, and we always have to solve for dx. So du over 2 is equal to dx. And anywhere we see a dx, we're going to replace it with this part right here, the du over 2. So now we can say that 0 to 1 is equal to the square root of 1 plus u squared du divided by 2. And then let's clean this up so it can look a little better. So we know that this is going to look like 0 to 1 square root of 1 plus u squared du. And then we can have that 1/2 over here because that's the same thing, because we have the du over 2 is just the same thing as a constant. So we just brought it out to the front. And one last adjustment to this is that it'll be 1/2 and then 0 to 2, because since we're doing things in terms of u, we have to adjust for the bounds. So up here where the u is equal to 2x, we're just going to plug in 0 and 1. So u is equal to 2 times 0, which is just equal to 0, and then u is equal to 2 times 1, which is just equal to 2, and that's how we get our new bounds in terms of u. So we're going to have that, and then that's, yeah, this here on the side is just showing you how I got the 2 from the bounds and whatnot, and the 0, and 1 plus u squared du. So now that we're in this form, we're essentially almost done. Now we can get this integral right here that I mentioned earlier, and then just put it in that form, and then all we have to do is just put it into that format. So we have 1/2 that we have from this expression, and then the 1/2 from the actual integral, and then we can do u times square root of 1 plus u squared plus natural log of u plus square root of 1 plus u squared. And then let's remember that the bounds are 0 to 2, so we're still going to do some bound calculations. We have some extra work from previous right here, which I can just erase. And then now we can clean this up a little more. So that would be 1 over 4. And then it would be, let's see, what do we have? We have 2 square root of 5, which is going to be 4 square root of 1 plus u squared, which is 2 squared, which is 4, plus the natural log of 2 plus the square root of 5 minus 0 plus the natural log of 1 and then from there, oh, I apologize, this is not a 4 over here, it is a 2. I computed it as a 4, but I meant that this is a u. Yeah, it's a 2. So our final expression should look like 1 over 4 times 2 square root of 5 plus the natural log of 2 plus the square root of 5. That is our final answer, which we can highlight. And then we can check off. Yeah, I hope you guys enjoyed the video. I know there was a few complex steps in there, but it's just about keeping track of your variables and then just making sure that the algebra comes out to how it's supposed to. And then let me know in the comments if you guys want me to show you how to do the actual integral of this bad boy right here. So until next time, this was Visual Math Pie, and hope you guys enjoyed it and learned something new.